Hi everyone, in this video we're going to talk about the demonstration of activity 5.
Invertebrates motor neurons are efferent neurons that originate in the spinal cord and synapse with muscle fibers to facilitate muscle contraction and with muscle spindles to modify proprioceptive sensitivity. Some important parts for the motor neurons that are important for the complete function of them is the dendrites, the soma, the nucleus, node of Renberg, the axon, and the demyelination.
Now I'm going to describe the three parts of a neuron. The nerve cell, also referred to as a neuron, has several parts that are important for its function in the nervous system. First, we have the soma, contains nucleus and other organelles. It is also responsible for synthesis of neurotransmitter. Dendrites are stimulated by other neurons and transmit the impulses towards soma. Finally, we have the axon, a single extension that extends from soma to the target cell. There are terminal buttons at the end of the axon where the synapse is located.
Now we have the sensory neuron that contains the cell body, dendrites, peripheral process, axon, and central process.
A bipolar neuron or bipolar cell is a type of neuron which has two extensions. Bipolar cells are specialized sensory neurons for the transmission of spatial senses, so as such, they are part of the sensory pathways for smell, sight, taste, hearing, and vestibular functions. The parts are the dendrites, the axon, the cell body or soma, and the synaptic terminals.
Now I'm going to give a description of the parts of a reflex arc and the purpose of reflexes. First, we have the receptor, that is either the dendrite at the distal end of the sensory neuron or an associated sensory structure. It responds to a stimulus. Then we have the sensory neuron. Is the nerve impulses travel from the sensory receptor along the axon of a sensory neuron towards the axon terminals that are located in the gray matter of the spinal cord. The central canal is one or more regions of gray matter within the CNS and is the simplest types of reflex. The integrating center is a synapse between a sensory neuron and a motor neuron. Then we have motor neuron. Is the nerve impulses from the integrating center leave the CNS along motor neurons to effectors. And finally, we have the effector, that are the parts of the body that respond to the motor nerve impulse, such as muscle or glands.
Now we're going to demonstrate the knee-jerk reflex. First, we have the student sit on a chair and cross one leg over the other so that one of his legs is hanging free. Then I am going to sharply tap on the patellar tendons just below the kneecap with a reflex hammer.
Now we're going to do another experiment. First, one student will need to sit with their arm resting on a table with the wrist hanging slightly off the edge with both the bond and index finger on top with the hand and a little bit open, like this. Another student will stand nearby with the ruler hanging over the seated partner's hand slightly. Then, the student holding the ruler will, without warning, drop the ruler so it will fall straight down between the other student's thumb and fingers. Like this. 1, 2, 3. Oh my god. The student that is having his reaction time test should try to grab the ruler as fast as he can after it is dropped. Like this, second try. Oh yeah. Repeat this experiment again with this student, but while he is being distracted by either talking with someone or texting with his cell phone. Try it again. Okay? distracted by either talking with someone or texting on his cell phone, try it again. Oh my god, another try. Now she got the rule. Now, applying the scientific method, the problem was to know the reaction time of my partner. My hypothesis was that my partner would have problems to grab the ruler. The independent variable was the time. The dependent variable was the reaction time. In conclusion, I can say that my partner had difficulties grabbing the ruler while she was distracted with her cell phone. This experiment helped us to understand each reaction time of the person.
Drugs that affect CNS. First, we have the stimulants. These ones act in the brain similarly to a family of key brain neurotransmitters called monoamines, which include neurofaminin and dopamine. See, some examples of these drugs are amphetamines, methamphetamines.
Antidepressant affects the central nervous system by slowing down the messages going between the brain and the body. One example can be the alcohol and the codeine.
Hallucinogens and dissociative drugs interact with the central nervous system, causing irregularities in body temperature, heart rate, respiration, and blood pressure. Some examples of these could be LSD, MDMA, PCP, DXM, and peyote.
Then we have the cannabis. Cannabis is a drug that comes from Indian hemp plants such as Cannabis sativa and Cannabis indica. People smoke marijuana in hot rolled cigarettes. It slows down the activity of the central nervous system and the messages going between the brain and the body. Smoking pot can increase your heart rate by as much as 2 times for up to 3 hours. Another drug is the cocaine. Cocaine, also known as coke, is a strong stimulant mostly used as a recreational drug. Users primarily administer cocaine orally, intranasal, intravenously, or by inhalation. It can cause feelings of euphoria, increased energy, elevated mood. The ecstasy is a synthetic drug made in a laboratory. Makers may add anything they choose to the drug, such as caffeine, amphetamine, and even cocaine. Ecstasy is usually taken orally in pill. Some of the effects that may experience after taking ecstasy include increased confidence and energy, lower inhibitions, and anxiety. Then the heroin is an illegal, highly addictive drug processed from morphine, a natural occurring substance extracted from the seed, pod, or certain varieties of poppy plants. People inject, sniff, snort, or smoke heroin. Once heroin enters the brain, it is converted to morphine and binds rapidly to opioid receptors. There is a wide range of effects from long-term heroin use, as severe constipation, poor appetite, and malnutrition. Finally, we have the methamphetamines. It's a powerful, highly addictive stimulant that affects the central nervous system, also known as meth, chalk, ice, and crystal. This can cause loss of appetite, nausea, disturbed sleep patterns, hallucinations, and panic.
Now we're going to define some concepts that are drug abuse. That is a compulsive, excessive, and self-damaging use of habit-forming drugs or substances, leading to addiction or dependent serious physiological injury, as damage to kidneys, liver, and heart. Drug addiction is defined as a chronic, relapsing brain disease that is characterized by compulsive drug seeking and use, despite harmful consequences. Drug tolerance is a pharmacological concept describing subjects' reduced reaction to a drug following its repeated use. Increasing its dosage may re-amplify the drug's effects. Then we have the withdrawal symptoms that are divided in two. First, we have the emotional withdrawal symptoms that are anxiety, restlessness, irritability, insomnia, headaches, poor concentration, depression, and social isolation. And finally, we have the physical withdrawal symptoms that are racing heart, palpitations, muscle tension, difficulty breathing, tremor, nausea, or diarrhea.
The difference between psychological dependence and physical dependence of a drug is that physical addiction is when your body cells can function without a substance or drug, you have become physical dependent. And psychological addiction is an addiction defined as a compulsion, perceived need to use. The risk factors associated with drug abuse in adolescents are early aggressive behavior. This risk factor is usually seen in early childhood, little parental supervision, peer drug and alcohol abuse, availability of drugs, and low income.
Some of the short-term consequences associated with drug abuse are low performance at work or study. The drug addict can be involved in aggressions or conflicts, deterioration and weakening of the will. Some of the long-term consequences are verbal violence, physical violence, mental gaps, delusions, and hallucinations. As a conclusion, we can say that drugs do not only harm the person who takes them. Around him, many other people suffer their consequences. Drugs interfere with the environment, family, and work, and can seriously compromise the learning process, especially in the case of young people and adolescents.